Okay, so yes, we've had some pretty awesome talks so far, talking about the need for a whole of systems kind of lens to the energy transition, the need to really think about the importance of resilience as we go through this transition. And today I'm going to talk very briefly about a project we're doing with Scion to look at developing a energy systems framework for bioenergy within the New Zealand context. So I work with Ara Ake. They are New Zealand's energy innovation agency. So they basically are there to accelerate the deployment and commercialization of energy innovation in Aotearoa. And we sit kind of in that early stage development of innovation as it starts to go to market. And we're always looking for the next big opportunity that could really accelerate our transition. Scion approached us about a year ago with a proposition that spoke to one of the challenges in New Zealand's transition, and that is the ability to lean into the bioenergy resource that we have in Aotearoa. I think the knowledge of our renewable energy resource from wind and hydro is well understood. What hasn't been as harnessed to as fuller extent is the opportunity of using other sources of waste for energy, and that is where Scion have developed a model to help evaluate where the opportunities can be and how to leverage them within that broader systems context, because it's quite a tricky thing to plan for in any case. So the project is pretty stock standard. It has involved working in the Taranaki region as a test case to capture all of the information available about the bioenergy resource, and then go through a number of modelling phases to look at the potential utilisation of bioenergy under a number of different scenarios. And that's doing that with as many stakeholders within the region, so local council, incumbent industry, innovators, and farmers, to identify what pathways could work to use that resource. So this is a little bit of an overview of what this bioenergy ecosystem looks like, and it is a bit different to the normal energy sector. As we lean into this opportunity, it means we've got to think about new partnerships, new ways of doing things, and that does require quite a lot of evidence to build that trust. The Scion's modelling framework is quite a comprehensive suite of tools to ask a lot of different questions. So it uses primarily a number of inputs of our environmental ecosystem, including all of the infrastructure and transport routes, and is able to ask very detailed questions as well as very high-level questions in a geospatial way. And the intent is to be able to roll this out across New Zealand to help with regional planning in other areas. So the challenge of gas within New Zealand's energy system was discussed nicely earlier this morning. Taranaki obviously being the hub for natural gas in New Zealand. So the obvious question was how much natural gas could be developed using bioenergy resources within the region. So that was where the project kind of started, knowing that there are lots of other uses of bioenergy as well. So the model basically focused on a number of regions within Taranaki and all of the available feedstocks, and then optimized all of those locations for how they could leverage those different organic feedstocks. and it was about 170 odd 744 potential plant locations were modeled automatically to identify where you might want to put a form of anaerobic digestion to create biogas. So the model has a number of different phases and capabilities, but the thing I thought I would just focus on here was in the baseline scenario, the idea was really to try and find out how much gas you could create for the lowest price within the Taranaki region, optimizing the existing transport routes and natural gas infrastructure. So there's a lot of pipelines already there, a lot of large industry already there. Where would the best locations be to consider creating organic gas? And of many of the phases, there is a two plant solution that popped out as optimal based on the current data that's going into the model. And it basically is able to quantify the potential value and cost of a plant in the North Taranaki region that would use a lot of wastewater sources, as well as a plant in the South Taranaki region using some industrial waste. And both of those could be complementary to each other, both could work within the region and be economically viable, but still significant capex investment if the region decided to invest in that. So that's kind of a starter for 10 for what the model enables the community to do. And we've just held a workshop recently to get feedback on the current iteration and work out what the next steps should be that we're going to model. And there is a lot of interest in other value add opportunities that can be done with organic resources in the region close by. There's the development of green methanol is being proposed as one of the new industries in the region. And all of these, the trade-offs and pathways to actually make that happen can be identified in this modeling framework. So this is one of the many steps that are kind of needed to look at, to give investors and communities and industries confidence in establishing this type of energy innovation. So we're expecting that this work is going to feed into a number of ongoing programs. ECA's started to look at leveraging wood resources a lot, as well as doing a follow-on study out the back of this on biogas opportunities off the back of their ITER work. And we also expect it to plug into Taranaki's spatial planning work so that it can be complementary to other energy investments in the future. And Ara Ake's interest in all of this is basically to help accelerate the next bit of innovation that comes out of this process. We're already working with a number of innovators that are basically waiting for the industry to be set up so that they can provide faster and better ways of leveraging organics. And that's it. Thank you very much.
Thanks a lot. So we've got some time for some quick questions.
Thanks, Dan. That's great. Really interesting. I'm interested in scale and bioenergy. So are there kind of minimal scales that you have to operate at in order to be economically feasible? And as you increase the scale, is that more feasible, or can you actually downscale and still be operable as a bioenergy unit?
It depends on the type of bioenergy. So anaerobic digestion can be really small. You can do it on a single farm and create a certain amount of gas from that. Whether it's worth doing it at that scale is that usually always been the consideration that it's not, that the bang for buck isn't necessarily there. When we're looking at some of the more complex things around methanation, for example, using organic sources, the scale of those plants usually is quite significant, usually in the hundreds of millions of dollars to build one of those plants based on current kind of searches we've been doing. So yeah, it does depend on the amount of conversion you're wanting to do to organic material to create energy and other types of outcomes. But yeah, this is one of the big things we are throwing around within the Taranaki region around how much should be considered as a centralized use of bioenergy so that other industries can piggyback off that. Whereas a decentralized model might mean that you can get a few more quick wins, but you can't leverage that investment for other things in the future. Yeah, good question.
Yeah, just a quick question for me then, Dan. The tool, is it, could you use it for other biomass resources? Is that the idea?
100%.
And what's the plan, I guess, to use the tool for beyond this study?
So the plan for this tool is really to demonstrate how it can be used to help regions evaluate their energy pathways and to complement the rest of their energy transitions as well. So whilst the obvious starting point within Taranaki was to look at gas yield, that is absolutely not the long-term interest of a lot of the players. They are looking at how Taranaki could create much different kinds of green fuels in the future as part of how it may complement its offshore wind investment. So yeah, the model has a suite of all known bioenergy conversion capabilities, and it basically goes through all of the options and spits out which ones appear to be appropriate based on what's available in region.
Great. Oh, so yeah, time for one more quick question, I think.
Just wondering, with the work, and you're using, like, for part of it, if it's using waste streams for producing bioenergy, did you have to consider any changes, like, throughout the year, I guess, in the build up of the waste streams, or is it reasonably kind of, I guess, non-changing in the region?
Great question. Yeah, New Zealand has very variable waste streams and feedstocks. In Europe, where anaerobic digestion, for example, is really, really prevalent, they have very consistent centralized waste streams that are really easy to put into an anaerobic digester. In New Zealand, things are very distributed, and you have to really be careful about what you put into the vat when, so that microbes can do their job. So yes, it's something you've got to be really onto, but there is a growing amount of work in New Zealand looking at that, as well as a number of pilot projects playing around with different feedstocks. And it's actually one of the things that's been proposed that could be part of Taranaki's kind of growing bioeconomy, that they may actually provide that as a service to other regions to establish how they could make the most out of the feedstocks from the different industrial or organic wastes within in that space.